Imagine standing in the Afar Triangle of Ethiopia, where the air shimmers with heat and temperatures regularly exceed 110 degrees Fahrenheit. Hot enough to make the horizon dance. The ground beneath your feet is cracking open, not in some distant geological past, but right now, at this very moment. Somewhere in East Africa, the Earth is splitting at about 6 millimeters per year, roughly the same speed your fingernails grow. Over the past 25 million years, that slow, relentless tearing has carved a scar across an entire continent. Over 3,000 kilometers long, stretching from the Red Sea to Mozambique. Scientists call it the East African Rift, and it's creating a new ocean right in the middle of Africa. We think of continents as permanent, solid, unchanging. But beneath the savannas of Kenya, the volcanic highlands of Ethiopia, and the lakes of Tanzania, something extraordinary is happening. The African continent is quite literally coming apart at the seams. The African plate is splitting into two separate plates, the Somali Plate to the east and the Nubian Plate to the west. And between them, a rift valley is forming that will one day become as wide as the Atlantic Ocean. Our journey into understanding this phenomenon begins with something dramatic. In September 2005, geologists watched in real time as a 60-kilometer crack tore open across the Afar region in less than 2 weeks. This was the largest single magmatic rifting episode ever recorded on land in human history. A blade of magma, 2.5 cubic kilometers of molten rock, forced its way upward through the crust like a knife splitting wood along the grain. The ground shook with 163 earthquakes, some reaching magnitude 5.6. In places, the earth widened by 8 meters overnight. Then, in 2018, another massive crack suddenly appeared in the Kenyan countryside near Mai Mahiu, tearing through roads and homes. It was over 15 meters deep in places. News outlets ran headlines claiming Africa was splitting apart before our eyes. Well, maybe not completely, because that crack was a surface rupture caused by erosion and seismic activity related to the deeper rifting process. But the panic it caused revealed something important. Millions of people live directly on top of an active continental rift, and the ground beneath them never truly rests. The East African Rift isn't a single crack. It's a complex system of faults, volcanoes, and subsiding basins forming two distinct branches. The Eastern Rift running through Ethiopia and Kenya, and the Western Rift curving through Uganda, Rwanda, and Tanzania. The Great Rift Valley in Kenya, with its dramatic escarpments and valley floors hundreds of meters below the surrounding highlands, shows the surface expression of this continental surgery. Early European explorers who first witnessed these landscapes thought they'd discovered the edge of the world, and in a sense, they had. To understand why Africa is splitting, we need to talk about November 24, 1974, when paleoanthropologist Donald Johanson spotted a fragment of arm bone jutting from sediment in the Afar Triangle. What he unearthed would change our understanding of human evolution forever. A 3.2-million-year-old skeleton they named Lucy, the most complete early human ancestor ever discovered at that time. Here's what makes this remarkable. Lucy exists because of the rift. The same tectonic forces tearing Africa apart created the Afar Triangle, a triple junction where the African, Somali, and Arabian plates are all pulling away from each other. The rapidly eroding highlands filled the Rift Valley with sediments, perfect conditions for preserving fossils. Some scientists believe the East African Rift didn't just preserve the story of human evolution, it may have caused it. We are quite literally children of the rift. But what forces could be powerful enough to tear a continent apart and reshape human history? The answer lies nearly 3,000 kilometers beneath our feet. In 2024, scientists at the University of Glasgow made a groundbreaking discovery beneath East Africa. By analyzing rare gases trapped in volcanic rocks, gases that could only come from the deepest part of Earth, they found proof of a massive plume of superheated rock rising from the boundary between Earth's molten core and its rocky mantle. Material from the very edge of Earth's metallic heart was pushing upward with enough force to tear a continent in two. Picture a massive bubble of superheated rock, hundreds of kilometers wide, ascending through the mantle like an inverted raindrop in slow motion. The temperatures reach around 1300 degrees Celsius, hot enough to melt rock instantly. The pressure exceeds 10,000 times atmospheric pressure. Rock is solid, but under crushing pressure and immense heat, it behaves more like thick honey than stone, creeping forward at centimeters per year, but with forces that can lift entire mountain ranges. As this mantle plume rises and pressure decreases, it begins to partially melt, creating magma that forces its way toward the surface. This is why the East African Rift is one of the most volcanically active regions on Earth. Mount Kilimanjaro, Africa's highest peak at 5,895 meters, is a volcano created by this rifting process. So is Mount Kenya, and then there's Erta Ala in the Danakil Depression, one of the hottest places on the planet. Erta Ala means smoking mountain in the local Afar language, and it's been earning that name since at least 1906, when the lava lake was first documented. It has been continuously active for over a century. It's in constant motion. A thin skin of cooled rock appears, then shatters as molten material surges from below. It's both magnificent and menacing, one of the few places where you can witness Earth's interior at work. In July 2025, researchers revealed a remarkable finding. The Earth beneath East Africa has a pulse. Molten rock rises in rhythmic flows like a heartbeat. In some areas, the magma moves 3 times faster than in others, creating volcanic hotspots where eruptions are more likely. It's as if the planet is breathing and we're only now learning to feel its rhythm. But the rift isn't just geological. It's intimately connected to climate. In November 2025, a team studying Lake Turkana made an unexpected connection. Climate and earthquakes are linked. When Lake Turkana in Kenya shrank thousands of years ago due to climate change, the reduced weight of water on the crust actually triggered more fault activity and increased volcanic risks in the region. It means that climate and tectonics aren't separate systems. They're coupled, each influencing the other in ways we're only beginning to understand. The human dimension became dramatically clear between September 2024 and April 2025, when dike intrusions, vertical sheets of magma forcing through the crust, triggered intense seismic activity in Ethiopia's Fentale Dauphin region. Multiple dikes, some stretching 50 kilometers long, generated earthquakes reaching magnitude 5.3. Approximately 75,000 people had to be evacuated. Remarkably, there were no casualties, but the event underscored a sobering reality. Millions of people live directly on top of an active continental rift, including the 5 million residents of Addis Ababa, Ethiopia's capital. So, what does this tell us about Earth's future? The East African Rift is essentially a window into the early stages of ocean formation. If we could fast forward 50 million years, we'd see the Rift Valley widen into a narrow sea, similar to the Red Sea today, which is actually part of the same rifting system, just further along. Eventually, that narrow sea would widen into a full ocean with a mid-ocean ridge generating new seafloor, just like the Mid-Atlantic Ridge does today. East Africa isn't alone in this process. If you travel to Iceland, you can visit Thingvellir National Park and literally walk between 2 continents. The North American and Eurasian plates are pulling apart there at about 2 centimeters per year. In the western United States, the Basin and Range Province is stretching. The Gulf of California is an active rift moving northward, and some geologists speculate that in tens of millions of years, Arizona could sit on the edge of a future ocean. Continental rifting is actively occurring in multiple places around the globe. But here's where scientific humility becomes important. We don't actually know if the East African rift will succeed. Continental rifts don't always complete their journey. Sometimes they abort, leaving behind failed rift systems like the Mid-Continent Rift in North America, which tried to split the continent a billion years ago and then just stopped. Research published in 2024 on the Ririba Rift in Ethiopia showed that rifting there actually aborted around 2.5 million years ago, even though it had been actively spreading for over a million years before that. The forces that drive rifting are complex, and they can change. Currently, scientists estimate that if rifting continues at its present rate, complete separation could occur anywhere from 1 million to tens of millions of years in the future. The uncertainty in that estimate, spanning an order of magnitude, tells you how much we still don't know. We're trying to predict the behavior of a system that operates on timescales of millions of years, using data we've only been collecting for a few decades. Despite all our technology, GPS networks that can measure millimeter-scale movements, satellite radar that can detect ground deformation from space, seismic arrays that listen to the planet's interior, we've barely scratched the surface. We've mapped the surface of Mars in higher resolution than we've mapped the floor of the Rift Valley lakes. We have more detailed data about the Moon than we do about the deep structure of the mantle plume beneath East Africa. The East African Rift is one of the most significant geological processes happening on our planet right now, and we're studying it with a fraction of the resources we devote to exploring other worlds. The East African Rift didn't appear for us to admire, though it is undeniably spectacular. It appeared because Earth operates on scales and timescales we're only beginning to understand. A planet where continents are temporary arrangements, where oceans open and close like breathing, where the solid ground beneath our feet is actually flowing on timescales of millions of years. What happens in East Africa over the next million years will reshape the geography of an entire continent. And we're here right now, at the very beginning of that process, watching it unfold at the speed of growing fingernails. The final separation of Africa lies millions of years in the future, far beyond any human lifetime. But knowing it is happening gives us perspective. It reminds us that our lives are mere blinks compared to the slow march of geological time. I would love to think that future generations of geologists will look back at our early 21st century observations as the first tentative steps toward comprehending one of Earth's grandest transformations. But that will only happen if we commit the resources to study it. If we treat the rifting of Africa with the same urgency we reserve for missions to Mars. If the idea of continents tearing themselves apart fascinates you as much as it does me, subscribe to witness more of Earth's most powerful transformations, and leave a comment telling me which geological wonder you want to explore next.